to this webinar, jointly presented by OpenSpatial and EnTech Engineering. I'm Colin Hobson, and we will be looking at tools and techniques for locating leaks in utility systems such as water and wastewater. And I'll be introducing EnTech Engineering, who have a number of patented tools and great expertise in this area. Tamian Taylor from EnTech will be doing the bulk of the presentation, and I'm just recording the first few slides as we lost those in the recording of the actual live webinar. We'll show these contact information details at the end of the session if you are interested in further information. EnTech Engineering has been in business for over 35 years. It's a professional engineering firm, and they hold more than 10 international patents on their proven remote sensing technologies. Their focus is on subsurface infrastructure and asset management using non-destructive and non-invasive tools, and Tamian will be discussing those in the webinar. Here's a sampling of EnTech's prestigious customers, and Tamian will actually be mentioning examples for some of these Department of Transport or various large commercial enterprises. And I'm going to hand over to Tamian, and he's the expert from EnTech and will discuss the causes of leaks. Over to you.
A large part of the U.S. public water system dates back to basically shortly after World War II. And according to the EPA, essentially 30% of pipes in systems that deliver water to more than 100,000 people are between 40 and 80 years old, and with 10% of those pipes being even older than that. So to the next slide. So in that, what the aging infrastructure, the things that cause are the things that directly relate to the leaks are corrosion, failing joints, and pipes cracking from shrinking and swelling of soils. Essentially, if you have certain soil types, they're going to cause corrosion. Some of the joints will fail over time. They're manufactured to last a specific time period, and the soils can also affect that. And then the shrinking and swelling of soils is actually whenever you have the drought conditions where the soils shrink up and then you get rain and it swells, and it just changes the pressure points on the pipe and how the pipe is supported. So if you go to the next slide. The other issues that cause leaks typically are human error, so poor construction or repair methodology. You really want to make sure that people that are the companies that are installing or repairing your pipelines are following the manufacturing directions. We've seen in the past where we've come in to do a leak detection survey, and basically everywhere where the client had made a repair in the past was where we were finding all the leaks. And most of them had been repaired in the last year or two, so they should have still been under manufacturer warranty. So they got on the phone and started talking with them and basically come to realize that they hadn't been following the instructions provided by the patches and the clamps and things like that. And the other things that can cause leaks on your pipelines is basically construction and other utilities. So heavy equipment puts added pressure on the pipelines. And a lot of people rely very heavily on locating pipelines with the ineffective call before you dig services. Those are kind of known throughout the industry of not being very accurate. So anytime somebody goes to do more construction near your pipeline is at risk. So the next slide is the IWA, AWWA water audit table. Most of you should be familiar with this. If not, you may want to start getting familiar because, as Nick mentioned, a large majority of the states, I think it's almost 25 states now, have some sort of legislature that says that you have to do a water audit, or your leak loss must be below a certain percentage, or something that ties into this table. And essentially this was created because IWA and AWWA were finding that a lot of there wasn't a single standard to audit how much water you were losing. And a lot of the methods that superintendents and water operators were using were turning out results that were impossible, such as negative leaks, like you were gaining water, or leak loss that was above 100%. So essentially, the way you go through is you calculate the amount of water that you bring into your system, whether it's your own source or you're imported, and then you subtract out basically what has been billed and metered. So essentially for the water loss section, there's apparent loss and then there's real losses. And apparent loss is unauthorized consumption, so basically theft, or meter inaccuracies. And then your real losses are leaks from the transmission lines or leaks from service lines, things like that. And all of those basically help calculate your non-revenue water, which is what AWWA really pushes for people to turn non-revenue water into revenue water, because you're losing money and that's how you become sustainable, is by reducing your non-revenue water. So the emergency versus maintenance repair costs, what utilities need is a systematic approach to finding and repairing leaks cost effectively. And basically because scheduled maintenance is estimated to be 5 times cheaper than emergency water main failure, and those numbers are from clients that we've talked with, and that's not including any damage to property. So you can see in the picture where there's looks like a Ford Escape or a Ford Explorer in the hole. That's just the repair costs from the overtime, the emergency shipping of parts, anything that you need. Basically, that costs you 5 times what it would be as if you were to find it and fix it before it failed. So I'm not going to go too deep into this table right now because I've got it again at the end to kind of go through and reassess everything that we've talked about. But some of the technologies that we're going to be talking about are infrared energy pattern analysis, external acoustics, which is kind of your amplified microphones, and then your autocorrelators or data loggers. And then there's in-pipeline leak detection techniques, which are in-pipeline video cameras and internal acoustics. So to start with the external acoustics, the amplified microphone or the sonics, they work really well on small diameter pipes. But they can be ineffective on non-metallic and large diameter pipes, so you really need to have a metallic pipeline for them to work well. Economically, it's very variable. I've seen prices as low as $100 a mile, and I've seen prices as high as $3,000 to $5,000 a mile. They can have difficulty in detecting large leaks because essentially it's relying on the leak sound to travel down the pipe. And if you think about a pipeline as kind of like a balloon, if you blow it up and you slowly let the air out, you kind of pinch the nozzle, it squeals really loud. But if you just let go of it, it makes a noise, but it's not nearly as loud as that squealing, and that's typically what you're looking for. This technology is also very susceptible to noise not relating to the pipeline, so cars driving by, construction, airplanes overhead, all of that. And the repeatability isn't very high because it's very operator oriented and very subjective. There's no output, there's nothing, no files to be able to save. It's solely how the operator feels. A lot of operators or a lot of companies use kind of a high, medium, or low rating on how they feel if it's a leak, or a 0 to 5 scale, something like that. The digital correlators will work on both metallic and non-metallic pipelines, but again, the sound travels better on the metallic pipeline, so they are more effective on that. They can be affected by water softeners and other things that basically create sound or noise on the pipes, but they're less affected by unrelated noises such as the cars driving by or things like that. They can have difficulty with non-straight line paths, but they are very repeatable because they do output a file, and you can go through and basically do that same test multiple times and get very similar results. And a lot of times how people actually utilize these are they put them out during the day, and then they have them record at night when water usage is the least. So, and they can record multiple times. So the in-pipe inspection, Sometimes the pipe may need to be shut down for operation. It's getting to where a lot of the in-pipe inspections, they don't need to be. It is more repeatable than acoustic, the external acoustics. Economically, it can be very inefficient. It's $3 to $5 a foot, so that typically that puts it about $15,000 a mile. It does work on many pipe materials and sizes, and it can detect leaks of all sizes. And there's typically two different types of in-pipe inspection. There's acoustic and there's video. So the IREPA, it's fairly repeatable. It is cost effective. It's more expensive than the acoustics, but it's kind of a happy medium where it's not as expensive as the in-pipe stuff. It's compatible with any sized pipe or material because it actually looks for the water outside of the pipe or the sewage material outside of the pipe versus inside the pipe, so it's not dependent on sound or anything like that. And because of that, it also works on any sized leaks. But there are some restrictions as to when the technology can be used, and that it's typically weather related and having line of sight to the pipe. So the biggest question that we get is, how does IREPA work? And essentially the way it works is it's based on the law of conservation of energy. So energy is never created or destroyed, it just gets moved around. So during the day, the earth acts like a big heat sink, and then at night it releases that energy. So if you have a blacktop parking lot that was just paved and it's nice and uniform, and you've got homogeneous soils underneath it that are nice and uniform, that blacktop parking lot is going to heat up and cool down very uniformly. But if you introduce a water pipe or a sewer pipe, and especially one that is leaking, that pipe is going to have a different thermal conductance and thermal capacitance, and the leaking materials, the water or the sewage, is going to change the thermal conductance and the thermal capacitance of the soil surrounding the pipe. And those energy patterns will actually show up on the surface whenever the earth is absorbing and releasing that energy. So now I'm going to get into some example data from some of the different technologies. I don't have any data from the acoustic microphones because there's no files that you can save. Basically, you listen to it and say there is a leak or there isn't a leak. But this is an example of the digital correlator data, or they're also data loggers sometimes referred to as. And you can see here where basically down at the bottom half, there's where it's recorded all the sounds, and then in the middle is where it's actually correlated and said, okay, right here is exactly where we think the leak is. So you can actually go into a lot of the softwares and insert in the pipe length and the pipe size and the pipe material, and it'll actually calculate between the two correlators that you put out where that leak is between the two of those. So if you go to the next slide, this is some infrared data. This data was collected in the city of Chicago, and on the left you have a visual image, and on the right you have some IREPA data. And essentially you can see some cracking on the left in the visual image. There's some surface distress of the pavement, but there's not any water on the surface or anything like that. But then on the right you can see that there is actually water pooling underneath the roadway. And that was a leak that was confirmed on an 8-inch water line. You go to the next slide. So this is another example. You've got the visual image on the left and the infrared data on the right, and this was taken in the city of Greenfield, Missouri. And you can see where we actually marked a couple different spots here. I just have the box around the first two areas. But essentially, if you go to the next slide, this is the truthing image where basically they dug it up and there was a pretty good sized water leak. The next slide is the infrared can actually be collected from the air, or there's a van-mounted capabilities, and there's also handheld capabilities. So the image on the left is a water line for a project down in Texas, and that was actually a 4-inch PVC line. And you can see the signature around the pipe is kind of bow tie shaped, and that's a normal signature that you would see from an infrared signature on a pressurized pipeline. And then the image on the right is actually from the sewer, and that was from a band collected system. And essentially the white spot in the middle is the manhole, and then the area on the outside on the right that's boxed in, that's exfiltration, where the manhole was actually leaking. This is another example, if you go to the next slide, of sewer mapping and leak detection with the infrared. You've got the visual image on the left and the infrared data on the right, and this is a 48-inch sewer. And essentially, ExxonMobil was afraid that their sewer was leaking and they were going to have voids and it would cause this public roadway to collapse. So we were able to map out the sewer and tell them that we didn't think that there were any leaks or anomalies, as we like to call them, to help with the EPA on their system. This is more aerial. If you go to the next slide, aerial data. This is the visual imagery. And then as you're clicking through, you can go, it zooms in. If you click once, it zooms in. Okay, and then there you have the infrared data. Sorry, I'm trying to time it to the what you guys are seeing. Manholes, mapping lost manholes and valve boxes is something that we're recently finding that utilities are very interested in, and that's something that the infrared technology can provide very well. So we mapped out the manholes, and essentially some of those were buried beneath the asphalt, so they weren't visible from the surface. Electric lines and water lines and the sewer lines are the fiber optics and the steam and the sewer. All of this is able to be mapped via infrared. And then this particular system actually had leaks on the steam system as well. Click once more. So the infrared is very flexible in what it can provide. And then this is another example. The next slide is a manhole buried underneath it was paved over. So going back to the table to compare the different leak detection methods, so your infrared works well on small and large diameter pipes as well as metallic and non-metallic, simply because it's not listening for a sound on the pipe, it's looking for the water outside of the pipe, and you can also pick up voids with it. The external acoustics are very good at what they do, and they're very good at the small diameter metallic pipelines. And here it's kind of a fuzzy line on what's considered small diameter. Typically 12 inches is about where people start to say after 12 inches that's where you're kind of getting more into the it's 50-50 on whether it'll work. Sometimes it'll work great, it'll really surprise you on a big pipeline or a non-metallic pipeline, and other times you would expect it to work and it just doesn't. So like I said, the non-metallic pipelines such as PVC or concrete, transite, things like that are kind of shady. We have had clients and talked to people in the past that their leak detection, proactive leak detection approach was basically just a visual inspection where they were walking the area where the pipelines were. And we don't really recommend that. It's just not very effective. You're not going to find a whole lot unless it's coming to the surface, and at that point you're losing a lot of water. You could have found it in some other proactive method that would have saved you time and money. The in-pipeline video camera, they're good on small diameter pipes, and there are limits there. I believe most of them can go down to 4 inches or maybe a little bit less now. They're good on the large diameter, and they work on metallic and non-metallic, and it's the same with the internal acoustics. Like I said, they're very good technologies, very repeatable. They're also very expensive. And one thing as well is they don't necessarily help you find voids outside of the pipeline, which can lead to sinkholes. So if you go to the next slide, one thing that you always want to ask, or one of the questions that you always want to ask, is what kind of deliverables you're getting for your money. What you really need in today's world is GIS documentation, something that will go easily into your GIS. Whether, hopefully it's provided by OpenSpatial since they're providing the webinar. But you want the data to go through. If you click once more to show the water lines, essentially you want to have your water line information, and then if you click again, you want to be able to plot the leaks that you found and repaired in the past so that you have that history. And then other pertinent information that you would want to have are fire hydrants. If you click once more, and click once more, and the valves as well. And this is pretty standard. There are lots of different companies that provide GIS, so it's something it's really necessary going forward for operators to have. And if you click to the next slide, and really what you want is all of the information that's collected by the leak detection company to be able to integrate that into the GIS. And I know with working with OpenSpatial that they provide the ability to be able to easily integrate all the different data that is collected, such as the infrared, the sound files from the digital correlators, street addresses, all of that. And if you go to the next slide, basically this is the kind of a minimum of the deliverables that you should ask for, and it doesn't matter really what format it's in, but you want to be able to relocate the areas, your repair crews to be able to relocate the areas that were marked as leaks. So you need street addresses or right-of-way indexes. You need visual imagery so that they can, rematch it up in case paint marks are washed away. Latitude and longitude is good information, and typically you need to be down to, I believe it's 6 decimal points to be able to really find the area. And then a lot of times it's really good to ask for a priority as well. That way you kind of know where to start or an estimated leak loss, things like that, so that you know which ones to start with, and you're not wasting your times on the little ones whenever you have big ones that should be fixed first. And if you go to the next slide, we like to end with a joke. Essentially, if you don't take care of your utilities, our beer delivery is at risk. And this picture is actually from Anheuser-Busch here in St. Louis, or MTech is out of St. Louis, so here in St. Louis, and they basically lost an entire beer truck full in a sinkhole in their plant here. So if you go to the next slide, if anybody has any questions.
Yeah, Tamian, thank you so much. Can you hear me, Tamian?
Yep.
Excellent.
I can.
I just want to jump in just for a moment. Thank you for that presentation. We are at the top of the hour now. We, Tamian and us at OpenSpatial, we have some additional time. We just want to be respectful to those of you who may have an appointment, may need to jump off. The easiest way to get more information would be simply to, in the chat box, just type in a couple of times that would work for you for us to follow up with you, and I will put my email address. Oh, okay. We're going to show the next slide here so you can see. I'll put my email address in here as well. So if you prefer to just send a couple of times that work for you for a follow-up, we will get you in the schedule. But we will stay on for Q&A, and we can also possibly spend some time addressing individual situations after the Q&A. So, Tamian, before I open it up for questions, is there anything else that you want to say?
I think I'm good. I'm ready for questions.
Excellent. So I'd like to ask also the group, we've got 25 folks on here. How many of you found this information useful, just by a show of hands? All right, we've got a lot of hands coming up. We also want to, yes, so Eric, I see you, and Trong, and Tali, Robert, Chuck, Ray. Wow, you were very interesting, Tammy, and Wendy, so thank you. And if you have specific questions, I'm going to put the hands down right now. Go ahead and raise your hand again. I can unmute you if you want to ask a question.
Also, just at some point, keep in mind, Nick, I think there was a poll, if that's still available, that you may want to do now or later, but just something to keep in mind.
Yeah, I think we're going to follow up with that
okay.
After the fact. At this point, I know we did talk about that, Tamian.
Okay.
We did have a couple of questions. So these are typed in. So I'll start with these. I've got a very small window here, so let me see. Like this. Okay, I'm going to go ahead. I'm going to go ahead and read a couple of these. So our first question is from Tali. I hope I'm pronouncing that right, Tali. You showed manholes, exfiltration, how about infiltration?
Right. So the principle is essentially the same, but instead of the liquid going outside of the pipe, you have liquid coming in, or you have a void from where liquid has been coming in the past. So those voids can actually be detected. And I guess essentially the reason why there is a void is because you have that liquid that basically liquefies the soil, turns it muddy, and then washes it into the sewer, and it washes away that soil and the supporting structure. So that void should actually, or will actually show up. We can't tell you if it's infiltration versus exfiltration, but we can tell you that you've got an issue there.
Excellent. Thank you. And, oh, we have Chuck Hansen on. Chuck, my plane mate flying back from Vegas last week. Good to have you on, Chuck. Chuck is asking, how do you calculate quantity of leaks instead of high, medium, and low priority?
So as far as I know, there's not any kind of an industry standard or any kind of tool right now that will give you, that'll just output a standard, this is how many gallons per minute you're losing. The large majority of companies that do it, it's based off of experience from using the tools and just the true thing that they've had with clients where, okay, I know kind of what this one sounded like, and then whenever the client dug it up, it was, say, 5 gallons a minute. So every time I find one that's, whether it's with the infrared or some of the acoustics, and I know that it looks like that, I'm going to guess that it's, 5 gallons a minute. So I don't think that there is an industry standard or any of the technologies that will tell you how many gallons per minute it is. It's just an estimate based on the operator's experience and what the results they're getting from the technologies. Gotcha.
Okay. And Chuck is saying thank you, and he's asking for your email address, which I thought was on the slide here. Let's take a look.
Well, we have the info at Intech World on there. If you use that one, then I will get the email, and I'll be the one responding to that. So that's the easiest. Or my email address is T as in Tom, D as in David, Taylor, Taylor, at Intech Engineering, or intechworld.com.
All right, and I'm just typing that into the chat box here for you, for everybody. So tdtaylor@ntechworld.com. So I'll send that out via chat. Yeah, keep the questions coming, you guys. Appreciate your attendance. So just to be clear on Chuck's question, Tamian, so really I understand as far as calculating volume. What about quantity of leaks in terms of number of leaks? Is it pretty much the same answer?
Well, the number of leaks, like I'm assuming you mean before somebody comes in and does an inspection, there's really not any kind of a standard. It really just depends. It's so variant from system to system. I know one client that we've had in the past, their system was very old and they basically hadn't spent any money in the last 40 years to make repairs, and they had more than one leak every mile. And then we have other clients where, we don't do it super regularly. We usually try and do their entire system, once every 3 years or something like that. And people that have been taking a proactive approach and, all of that, they may only have one leak every 3 miles. So there's really no way to know how many leaks you're going to have until you get into it. And it can vary wildly from area to area, just depending on the pipeline type and the soils and all of that. We've seen in the past where essentially, because of the way that the pipes were laid, for a 2-mile section or a half-mile section, there's basically a leak every 20 feet, at every joint in that pipe. And then we've seen other areas, where we've gone, a 10-mile stretch on somebody's system without finding a single leak.
This is also it's also one of the things that OpenSpatial does in terms of tying these two data sets together, such that you can put the quantity and estimated quantity, but also the number of leaks per linear foot of pipe and then start building out a rating analysis so that one gets an overview of the system and prioritize things based on things like, diameter in terms of how important they are, but also where they are, so that you can map that all out and do a prioritization rating on that data. So that's something that we would, OpenSpatial would typically do with the GIS by combining these data sets.
And that mysterious voice was our North American director, Colin Hobson, here at OpenSpatial. Thank you. Thanks for weighing in on that, Colin. We have some other questions here. Charlie Wilson, thanks for your question. Most of the IR data showed results over paved areas, but 90% of our water lines are in the shoulder of the road. What kind of results can I expect?
So that really depends on the maintenance level of the shoulders. We can find leaks in grassy areas, and the infrared and the acoustics, all of that will work in grassy areas. It really just depends on how tall the grass is, or if there are trees, things like that, because we need direct line of sight for the infrared of the area above the area above the pipeline. But the acoustics, depending on the type and the material of the pipe, may be a very good alternative. It really just depends on the ground cover and how that's maintained. Is that a good enough answer, or do I need to go into more detail?
No, that's great. We're just working out some internal technology here. So I want to thank Kenneth Stewart from City of Fullerton is interested in a demo. So what do you propose for Kenneth and others that want to find out? We're still open for questions, but what do you propose, Tamian?
So essentially, it's best to either email me or talk. We can talk on the phone and kind of figure out. Basically, this is the best customized solution for you, whether it's to use the acoustics or use the infrared and the acoustics, what kind of timeline you're looking at, how many miles you want, what the budget is, all of that. So that's kind of where the free consultation or that kind of thing is where that comes in. That's the easiest way to figure that out.
Excellent. And Kenneth has a follow-up question. This is designed to be an information-based webinar, so we want to be really sensitive to that, but there have been a couple of questions about cost. The average cost of adding this equipment to existing vehicles, there was another inquiry about cost. Are you comfortable sharing generally in that category?
Sure. So in the past, we haven't licensed anyone to use the technology on their own, so we kind of provide the service. And like I said, we typically like to provide a customized solution, and what that typically is a combination of the infrared with all of the traditional tools, so the ground mics, the amplified microphone, and the correlators, that kind of thing. And normally for that, just depending on the size of the project and where it's located in the country, we try to come in somewhere between 2 and 3K per mile. And again, it just depends on the size of the project, the access to the right-of-ways of where the pipelines are, and then how far we're going to have to mobilize, all of that.
Okay. Excellent. So, definitely want to encourage individual follow-up meetings over the web, which are without charge. Is that right, Tamian? To find out their specific situation a little better, to give them a more specific idea.
Yes, sir. We do not charge to put out proposals or anything like that. And we don't want to put together a proposal or provide, some off-the-shelf standard solution to everyone. We want to completely customize it to what your system's needs are, and then we'll get that information from you and discuss, and then put together a proposal, and then if you take it, great, we'll come do the work, and if you think you need something else, then that's fine too.
Yeah, so the easiest thing to do would just be to email me or email Tamian. Both emails are in the chat box there, and we just give a couple of times that work for you. We'll set up a half-hour meeting over the web, to discuss that more specifically, and we may be able to discuss a couple of scenarios. At the end of our Q&A here. We still have 17 people on, and I really want to applaud you for your attentiveness because, part of the webinar functionality here is, it shows who's actually looking at the presentation versus, being on other screens. And we've been at 100% attendance view pretty much the whole time. So you are very compelling, Tamian, apparently.
Sorry.
And, let me see what else we have here. If you have any other questions, feel free to type them in. I think, yeah, Charlie said he was going to follow up with you via email. If there are any more questions, please feel free to type them in the chat box, or we're getting intimate enough here in our numbers that if you want to raise your hand, I can try to unmute you and you could ask it verbally. So I'll give you another minute here. I'm going to just lower, yeah, I'll give another minute or two here to see if anybody wants to type in any new questions. Or raise your hand. And again, you'll see in the chat box Tamian's email, tdtaylor@ntechworld.com or nlynch@openspatial.com. We can get you set up with a follow-up. Okay, so, Tali, average results delivery time, Tali is asking.
So for our combined infrared and acoustics, we typically do between 5 and 8 miles a night for the data collection, and it can be up to 10 just depending on the, everything's rolling. We're not finding a ton of leaks. Everything's going smooth. We can do 10 miles on a night. But typically we're between 5 and 8. And then for every probably 2 to 3 days in the field, so say every 15 to 30 miles or 15 to 25 miles, takes about a day in the office. So normally we can turn out a pretty good, say a 50-mile project. We'll spend probably 7 or 8 days in the field, and then we'll have a 2-week turnaround on the reporting, or the deliverables.
Nice. Excellent. All right, just looking to see if any more questions have come in. So feel free to type them in or raise your hand. And, I did mention that we could spend, 5 minutes or so on individual scenarios if you want to. Of course, you can schedule a half an hour by emailing Tamian or myself. But if any of you would like to discuss a little bit your situation and spend a little bit more time, addressing your needs, just go ahead and raise your hand, and I'll try to unmute you and see if we can kind of get into some nuts and bolts here. I think a question just came in. Let's take a look here. Kenneth Stewart. All right. How deep does the radar penetrate in feet?
So the radar, the infrared. Sorry. Okay. Yeah.
Probably infrared.
So, yeah. Sorry. Most of the leak detection that we do, the pipes are between 3 and 10 feet deep. We can do deeper just depending on the situation. I guess on the utility side, most of the leak detection that we do, the pipes are between 3 and 10 feet deep. On the oil and gas and the nuclear and some of the other, more industrial type projects, those pipes are typically 15 to 20 feet deep. It really just depends on, kind of a lot of variables. Soil composition, how big the leak is, what the area above the pipeline looks like, whether it's, a paved roadway or a parking lot, or if it's out in the middle of a field, kind of all of that comes into, play. You know, time of year will affect it a little bit. But typically the stuff that we're finding leaks on for utilities are between 3 and 10 feet deep.
Excellent. But certainly has the capability to do deeper if needed, huh?
Yes.
And yeah, Kenneth did clarify that he was asking about infrared. So, terrific. Yeah, any other questions, just type them in the chat box, or if you want to discuss your situation in a little more detail, we do have about a dozen attendees still on here. Feel free to just raise your hand and we can get into a little bit more detail. Also, via email or in the chat box, if there are other topics that are of interest to you for future webinars, we'd love to know about those as well. So, any other questions for the chat box or anybody who wants to volunteer to be unmuted? All right. Well, Tamian, I really want to thank you for taking the time and sharing all this valuable information. And stay tuned. We'll notify you via email about other topics that will hopefully be just as interesting. Tali is saying, good presentation. Thanks, guys. We'll be in touch. And he was also asking if you've used infrared in Connecticut.
Not that I know of. I know we recently did a project in Manhattan with Con Edison looking for dielectric oil leaks. And we have done water leaks in New Jersey.
The two commuter towns for New York City, so that's close enough, hopefully, Tommy. Do you think infrared would work in Connecticut?
I would assume that there's not some kind of special soil or magnetic field or something that would mess with the technology there.
Fantastic, fantastic. Thanks for your questions, Tommy. Let's see. Ken Urban has a question. Does snow cover affect infrared?
Yes. Essentially, snow cover or ice or ponded water, basically all you can see is the reflected signal, so you can't actually see the ground area, you know, where the energy patterns are coming to the surface. So yeah, we have to do the work when there's we can do it whenever it's extremely cold out. That doesn't affect it, but if there's snow cover or ice or, you know, ponded water, then essentially we can't do it at that time.
Okay. All right. Good to know.
You know, the acoustics will still work. I mean, if it's kind of an emergency type thing, the acoustics will still work, but the infrared will not.
Great. Terrific. So any other questions, feel free to type them in the chat box, or if you'd like to be unmuted, go ahead and raise your hand. Okay, folks. Well, I think, we've got a dozen or so still on, but if there's not any other questions for the chat box or anybody raising your hand, I think we'll go ahead and wrap it up for now. And again, Tamian, thank you for your time. Once again, you can see on the chat Tamian's email address and tdtaylor@ntechworld.com. If you want more information or if you want to discuss your specific situation for, a half an hour over the web at no charge, you can, and I'm reachable. This is Nick Lynch at OpenSpatial at nlynch@openspatial.com. I'll go ahead and close it down now. But again, thanks to all of you, and we look forward to seeing you on the next. One more question from Kenneth. This is why I stall. Where's NTech located? So you're pretty close to Kansas City there in Missouri, right?
Yes, sir. We are out of St. Louis, Missouri.
But you service a wide range. I mean, you're pretty much nationwide or beyond in terms of your area of service.
Yes, sir. We will travel for work. We've done work just this year up and down the East Coast, like I said, out in Manhattan and a little bit further down in the East Coast. And then we regularly do work in Texas, starting to get maybe a little bit over in New Mexico, and then, Kansas, Missouri, Illinois, Indiana, Michigan, Kentucky, Tennessee, So not a whole lot on the West Coast, but we're not opposed to going to the West Coast or anything like that.
Yeah, we've got a great satellite office for you to operate out of while you're here. So
There we go.
excellent. Excellent. So yeah, we'll just give it one last chance here. Any other questions? Go ahead in the chat box, or if you want to raise your hand to be unmuted to talk about your situation, we'll give you a second to do that.
Yep. And I'll just thank you, everyone, for your time, for listening, and thank you, OpenSpatial, for providing the opportunity.
Wonderful. Thanks again to you, Tamian. Have a great day, everybody.